Hello and welcome to this tutorial on how to get going with the Intel Edison board with the Arduino breakout board. I'm going to show you how to get the board up and running, how to erase it so you have a clean system with the latest firmware, and then how to connect it to the IBM IoT Foundation Cloud. So let's get started and have a look at the board. So here we have the board. You can see that I've already attached the Edison module, which is this module here, to the main breakout board. One thing to be aware of, this little switch here, make sure it's towards the small micro USB port, not towards the large USB port in the power socket. So this switch needs to be in the down position as shown here. To power the board, you've got a number of options. You can provide a 12 volt power supply here, or you can connect this port to your computer USB port or a powered USB hub. One thing to ensure is that your laptop USB ports provide sufficient power. So I tend to use a powered USB hub or the 12 volt adapter. Here we are in Microsoft Windows 8.1. This is a fairly new install and it's just got all of the latest Microsoft fixes applied. So the first thing we need to do is download some software. And we need to go to the Intel site for the Edison board. Okay, so that's Intel IoT Edison, and that will get us to this site here. It's the software intel.com and it's the IoT hardware Edison. And here we go. And we're going to follow the Get Started guide. When I showed you the board, I already had assembled my board, so I'd attached the Edison module to the Arduino expansion board. If you haven't done that, you can follow the guide here to help you get the board assembled and attach the Edison to the board. Once you've done that, we're going to install the required software, and we're on Windows. So we're going to save that. Now some of this software does require a Java virtual machine. So I'm going to install Java 8 SDK from Oracle. There's a download there. So first thing you need to do is accept the license agreement, and then we're looking at the Windows 64-bit download. And again, we're going to save that. And then the last bit of software we need to download is Putty. This is going to allow us to communicate over the serial link to the Edison board. So the official site is here. And go to the download section, and we want the Windows installer. So that's it here, the Windows installer, and we're just going to download that and save it. So we've now got the three components downloaded. Just need to wait for the Java machine to finish. Okay, so all this content's downloaded. First thing we're going to do is install the virtual machine. And I'm just going to go through and accept all the defaults here. So that's job installed. Now we're going to install the Intel IoT DK. So now we need to connect the Edison to the computer. So you need the two serial cables with the micro USB. You can use the power adapter, or you can just use the two serial ports. To connect the board, you connect the power first and then the USB ports, and we will use both of the ports during this exercise. So that's the two serial ports now connected, and you'll see that Windows has recognized the devices, and we just need to wait a little while until the devices become registered. So you'll see that we've now got an additional drive added to Windows, and the next button is now available. So you can just select that. The installer gives the option of adding some additional developer software. By default, we get the Arduino environment. You can program the Edison as if it were an Arduino board. It's fully supported. You can also install the Intel XDK, which gives you a JavaScript, a Node environment, and Eclipse will give you a C++ developer environment. For this video, I'm going to show you how to install an open source tool that uses a browser and a visual environment to program, so you don't need these additional components at this stage, but feel free to select them if you want to install them. So here we need to disconnect the Edison board. So now we're going to connect the board again, and then we're going to do a power cycle. So as the instructions on the screen show you, you're going to hold the power button down for 10 seconds. That will shut the board down, and all the LEDs on the board, the green LEDs, should go out. And then if you hold the power button down for a second, the green lights will come on and the board will power up again. So that's the board connected. Then hold the power down for 10 seconds. And the board is now disconnected. So now I'm going to push it down again for 1 second. The green LED's on and the board's powering up again. Don't worry if you get an error message like you're seeing on the screen. I always seem to get this error when I install the software, but I'm about to show you how to reflash the board manually, which will allow you to reset the board if you want to delete everything and reset it back to a new state. So we've now got all the Intel software installed, and the last thing we need to install is PuTTY. So again, just accept all the defaults to go through and make that install. So that's all the software installed. The next thing we need to do is find out where the board is connected into Windows. So to do that, we need to launch the device manager. I can get to that from the control panel in the hardware section, device manager. I could also type device manager in here and be shown a link to it. Once you're in the device manager, you're looking for the port section. And when the Edison board is connected to the laptop, you should see a USB serial port and the Intel Edison virtual COM port. They may be in different ports on your system depending on the setup. The port you're looking for is this one, the USB serial port. You need to remember that COM, so for me that's COM3. So once you've identified which COM port, you can close the device manager, and then we're going to launch PuTTY. So PuTTY, and then making sure you've got the session category selected, you want the serial connection type, type in your COM for that USB serial port, which is COM3 for me, and then 115/200 is the speed. And once you've completed that, hit open. That opens up the COM port, and to connect to the system, just hit enter. And that should give you a log on to your Edison board. Type in root as the user. If this is the first time you've connected to the board, you'll be logged straight on. If you've used the system before and set a password, you'll have to enter the password. And here we are logged into the Edison board. So the first thing we're going to do is do a reflash and reset the board back to a new condition. So with erasing all of the previous content. When I do a reflash, it actually does maintain whatever's in the home directory. So anything in the home directory will not be deleted during a reflash. So if you want to clean the board off, the first thing you've got to do is go and clean up that home directory. You do need to keep the root user directory. So if I go to the home directory, you'll see that I have the root user directory. You do need to leave that alone and leave that directory there. But what we want to do is we want to remove all of the content of that directory. So rm minus rf with an asterisk will get rid of all of the normal files, and then rm minus rf asterisk, dot asterisk will get rid of all of the special files that start with a dot. So here we are, we've now got a clean home directory for the root user, and we can now reflash the board. So if I open up the file manager and look at this PC, you will notice that we have an Edison drive. For me, that's drive E. And to reflash the board, we need to copy the new image onto this drive. So first thing to do is go back to our Intel site, and we want to go to the download section. Once there, if you scroll down a little bit, you will see the Edison board firmware software. And what you want is the latest complete image. So just click that to download it, and we want to save that. While that is downloading, if we open up a command prompt to our local system, we can then go to the E drive, and if I do a dir, you'll see that there is quite a lot of content on there already. So I want to del, and I want to do a /s/q and then asterisk. And that will delete all of the files and all of the files in all subdirectories. So then we need to just rm directory helper if you do a -s, it will delete all subdirectories as well, and rmdir uboot env. So now we've now got an empty file system. So if I open up the folder, you'll see that I've got the image downloaded there. And what we need to do is we need to extract that and expand that into the Edison drive. So the easiest way to do that is to right click and say extract all. And then when I say destination, hit browse, this PC, and then go and select the drive. For me, it's the E drive. It may be a different drive letter for you, so just wherever your Edison connected to, select that drive and say OK, and then extract. And that will extract all of the files into the Edison disk. Okay, so that's now complete, and we've got all the files of the new image on the Edison board. So back in the PuTTY window, to get the system to reflash, we type reboot and then OTA. So this command will cause the system to reboot, and then it'll reflash the Edison before starting up again. So here you can see that we're actually reflashing the system now. We're writing the new image onto the Edison board. So you see the message, we've now successfully reflashed the Edison board, and we're now going to reboot the system as normal. So here we are, ready to log in again. So type in root. And this time for me, you'll notice I don't get prompted for a password. We've now got a clean system. So if ever you need to reset your board, you can go through the process we've just gone through. Reflash the latest image, and if you clear out the root home directory, you're back left with a clean system. So next we want to set up the system. So there is a nice utility in the Edison image called configure_Edison. And if I just hit the enter key here, it'll give you a list of all of the options available. So what we're going to do is we're going to go through the setup, which is going to change the name, the password, and set up Wi-Fi for us. But I can do these options separately. If I ever need to find the IP address for the board, I can do configure Edison and show Wi-Fi IP. And there's a few other options here as well. So we're just going to say configure Edison -- setup. And this is going to go through a series of prompts to get me to set the board up. First of all, it asks for a password. This is going to be the root user password. And now it's going to ask for a device name. A number of the software development tools use network scans to identify Edison boards. So if you ever go to a hackathon, or if you're on a network where there are multiple devices, it's very useful to have your device uniquely named. So I recommend you do give it a name. And then lastly, we're going to set up Wi-Fi. And here you'll see that we do have an IP address, and I can just verify that everything is okay. If I just go to HTTP 3, if I just go to the IP address given, then the Edison board should respond with this page, just confirming that it's your device and that's the IP address. So that is the board effectively set up now. So the next thing I'm going to do is show you how to install a software development environment called NodeRED. This is open source software, and it allows you to visually program the Edison board. So if you just type in NodeRED, NodeRED.org, this is the software we're going to install. Now, it normally tells you to install it using this command, but it's slightly different on Edison. If I look at the file systems and see where the free space is, you'll see that I have most space available in the home directory. If I do an install -G, it will put NodeRED here, which is the system root directory. And it's not really a good idea to fill this up, and NodeRED will more or less fill this up. So I'm going to install it to my local directory. So in my root home directory, what I'm going to type is npm install. And I'm going to put unsafe I'm going to put that option on. This allows you to install packages, node packages, using the root user, and it will remove the warnings that you get when installing as root user. You can leave that option off if you want, but it just tidies up the log, so if there is a problem, you can see what real problems are, and you remove the clutter of warnings about installing as root. And then it's NodeRED. So this is using Node, and all of the Node environment is pre-installed within the Edison image. Okay, so that's NodeRED now installed. So one of the results of not actually installing it locally is that the NodeRED command is not available to me. So if I just type NodeRED, it's not available. So what I want to do is make that command available. And I can do that if I come into my user bin. I can do ln-s home root node modules bin NodeRED, and I can link that to a local NodeRED. And similarly, there's another command that I can also link. So now, anywhere, I can type NodeRED and that will actually start the program running. So just by typing NodeRED, that starts the program running, and by holding the control key down and hitting C, that will stop the program. So normally when I run, I actually want to put an additional parameter. Because we're on a limited resource system, we can put on an optional parameter called max old space size. And that just makes Node be a little bit more efficient with the use of resources on the board. So that's what we'll normally type to run the application. So that's NodeRED up and running, and to access it we launch a browser and we're on port 1880, and again it tells us that down here that we're on port 1880. So we just hit enter. We get the NodeRED environment running in a browser, and that's actually running from the Edison board. NodeRED is a really simple environment to use. You've got a selection of nodes in the palette here. I just click and hold and then can drag a node onto my sheet. So if I have an inject and a debug node, I can put them on my sheet, and to connect them I just press and hold and then pull out a connection line and release it over the input there. So that's created two nodes connected together. To deploy a flow, I hit the deploy button, and then that's now successfully deployed. What the inject node does is every time I hit the button, it starts a message to go down the flow. The debug will output content to the debug pane, and optionally also the console, the program console. So hitting the inject, you'll see that I now get the message sent to the debug pane. So that's us running our first application in NodeRED. So the next thing I want to do is look at how to make NodeRED start up with the system. I don't want to have to start this manually every time. I just want it to start with the Edison board. So to stop NodeRED, again, hold the control down, hit C. That will stop the flow. I'm actually going to use a facility called PM2 to manage my environment. So again, in my root directory, I'm going to type npm install I am going to install this globally this time. We're going to use the unsafe perm to stop the warnings, and then the program is called PM2. So npm install -g --unsafe -perm PM2, and that will install the module globally on my system. So that's PM2 now installed. So the first thing we want to do is use PM2 to start NodeRED. So the syntax is PM2 start, and then we give the path to the application. So user bin NodeRED. And then I'm going to pass that max old space as an argument to the node runtime. So I do that by saying node-args equals double quotes Now, if I want to pass any parameters directly into the NodeRED application, I can do that. I need to put double dash, and then I can put any of the parameters that I want to pass through, like the V for verbose logging. But for me, I don't want to pass any additional parameters. We're just going to leave it with node arguments. So hit enter, and that will start the PM2 process, which will in turn start up my NodeRED application. And I can just check that that is running. I refresh that, and then I can click, and we can see that we're actually running. If I want to see what is running on PM2, I can do PM2. I can either do list, or I can use the shortcut of just the L. And that will show me the current process, the current state of processes running within PM2. If I want to look at a log, I can do PM2 logs, and then NodeRED. And this will give me a tail of the log. So that's going to keep streaming in real time the logs out of the NodeRED process. Again, hold the control and hit C to come out of that. The next thing I want to do is get PM2 to start up with the Edison at boot time, and then make sure it starts NodeRED automatically. So the first thing I need to do is create a new directory on the Edison board. So make directory, and it's the etc init.d directory. That must exist before I run the next commands. So once I create that directory, I do PM2 save, and that will save the current state of PM2. So whatever is running now will be started at system boot. So to get that to happen, I do PM2 startup, and that will ensure that whatever's we saved will be started automatically. So that's all set up and running. While we're here, just a couple of additional commands. I can do PM2 restart NodeRED, and that will automatically restart the NodeRED process. I can do PM2 stop NodeRED to terminate the process, and if it's not running, I can do PM2 start NodeRED to start the process. So what we're going to do now is we're just going to reboot to verify that all of that worked. So here we are, we've rebooted, so log in. And now when I do PM2L, you'll see that NodeRED has automatically been started, and we can see that we're up and running again. So the last thing I'm going to do is show you how to add new nodes. And one of the nodes that we want to install is the node to allow us to talk to the IBM Internet of Things Foundation Cloud. So if I go into the browser, and if I just type npm, this is where the packages come from for Node. And if I just type NodeRED, you'll see there are quite a lot of new nodes that allow me to speak to various things and do different functionality. So I can add new nodes that are created by the open source community, or I could actually go and create new nodes myself. But we want to install a node for the IBM Internet of Things Foundation Cloud. So if we go into our node modules directory and go into NodeRED, then we can install new nodes from here. So I simply type npm install, and the node we want to put is NodeRED contrib scx IBM IoT app. And that will install the new node into NodeRED automatically. So that's just installed it. If we now do PM2 restart NodeRED, so we pick up the new nodes. Let's give it a few seconds to start up. And then if I refresh, we should now see I have the IBM IoT nodes. We've got one for input, so messages coming from the cloud, and we've got one for output to send messages to the cloud. And we can test out this functionality. So if I drag the IBM IoT out node onto the palette. And then we're going to connect the inject node, so click and drag onto the IBM IoT app out node. To edit a node, I simply double click, and that will bring me up an editor for that node. There are two ways to use the IBM Internet of Things Foundation Cloud. One is using an API key, so I get authenticated messages, but we are actually going to use the quick start method. And the advantage here is it allows me to very quickly get started without having any to have any registrations or keys. The device ID is normally the MAC address of the hardware. So our wireless LAN MAC address with the ifconfig command, you can find that out. So I'll just copy that and I can paste that into there. And what we want to do is we want to remove all the colons. The device ID can't have the colons in there. So that's our device ID. Format is JSON. Event type is test. And the payload values are going to come out of another node. So that's the details included there. And then I want to just change the inject node, so double click on it. I want to inject a string, and that string is going to be in the correct format for the IoT. So I'm sending device data, and then I want to send a value of A with a value of 1. So that's just a JSON object sending a device packet, which is this object, which contains one value with a key of A and a value of 1. So that's now complete. I, don't forget, need to deploy that. So now if I inject that, you see that that is what we're injecting, that payload. And if I open up another tab, and then we want the quick start Internet of Things.ibmcloud.com. And then I just Control V to paste in my hardware address, my device ID. Again, remove the colons, and I say go. So now if you come back into NodeRED and we fire this message and switch back here, we'll see that we actually now have that message come in into the Internet of Things cloud. We've got our test event with a data point A and a value of 1. If I come back into NodeRED, and let's just change this value from 1 to 5, say OK, and then deploy. And now when I hit the inject, you see I've now got a value of 5, and on the Internet of Things I've also gone into a value of 5. So we're now showing the data coming in live on the IBM Internet of Things cloud. So we're sending data from our Intel Edison board through this node, which goes to the IBM Internet of Things Foundation cloud. Again, you can just change this down to 2. Say OK. Deploy to deploy the new flow. send the message, and then automatically we see the value updated here. And that's the end of this video showing you how to connect the Intel Edison board to the IBM Internet of Things Foundation Cloud.